All right, so let's talk about this. Is the situation described an observational study or an experiment? This is an observational study. What's the difference between the two, Eni? Yeah.
I was going to answer the question. I said it was an observational study because they didn't set up the test prep as an experiment.
I like that answer.
Procedure.
If there's an experiment, there has to be some kind of strict procedure. You have to do some work ahead of time, right? What's another really important component of an experiment versus an observational study? Everyone has to have the exact same thing?
Yes.
Close. We need to have the same number of people or a proportional number of people, approximately the same. Maybe I've got 101 people, so I got 50 in one and 51 in the other. But you have to have a control group and you have to have an experimental group. What's the purpose of the control group? To know what to base your results off of. This is what it looks like if we do nothing. Over time, maybe people just naturally improve on this. You wouldn't know that. You wouldn't know to compare it to that type of an idea unless you had that control group. So this is an experimental study. Explanatory and response variables. What would the explanatory variable be, Ben? Students that did or did not take the prep. So whether or not they took this. There's a couple ways you could word it. One of the things I want to make sure you don't write down for the explanatory variable, it's not just SAT prep class. It's whether you took the prep class or whether you did not take the prep class. What would the response variable be? Scores. Yep. All right, so let me get some of these ideas up. In an observational study, there's no treatment. That doesn't mean I'm not looking at anything and I'm not trying to figure out what's going on with that, but a treatment is specifically something that gets imposed on my experimental group and my control group does not get. The people involved in the study don't get to decide whether they're going to get put in the treatment group or the control group. In an observational study, the participants decide what they're going to do. They're not told what to do. So that's why we don't call it a treatment. It's just their choice. All right, so then we said explanatory, whether or not the prep class was taken. This is what we use to make our predictions with. Response variable, that's the SAT score. That's the outcome. That's where we're looking to see if that explanatory variable had an effect on it. I love question number 3. Can you conclude that taking an SAT prep course will cause a student's SAT scores to increase? This is the super important word right here. No, you cannot conclude that it is causing increased scores. Oh, sorry. We could find out whether or not there's a correlation, whether or not there's a relationship between them, but we can't determine cause unless it's an experiment. An experiment, because you have that control group to compare it against, and because our two groups should be identical in every way except for this treatment, if the only thing that changes is the treatment, then we would be able to establish cause with that. But because people are making their own choices on this, this treatment has not been imposed, maybe they're doing something other than just taking the SAT prep class. Maybe they're engaging in other behaviors that are going to improve this. We don't know. So we cannot determine cause. Number 4. Identify as many other possible variables that you can that might explain why the SAT scores are higher for those who took the prep course than for those who did not. What do you guys think? Yes? How much sleep they got. I love it. Anybody else? Yes. Amount of free time they have after school. Motivation. I love it. What else could explain this?
I said if they might have retaken it already, like in the past.
Yeah, maybe they've taken this test already. We do know that people that take it more than one time tend to see improved scores each time. Yes? Yeah, going into the test with different expectations. Some of the ideas that I came up with, available time, so that's what you hit. Practice, taking it more than one time, or taking practice tests. Maybe you didn't take the SAT once already, but you have practice tests. Guessing, maybe they got lucky. Motivation level, maybe some people get extended test time. Whether or not the college that they have their heart set on needs a specific score. If you need to get a high enough score to get into the school of your dreams, you might work a whole lot harder for that. So these are what we call confounding variables. Confounding variables would be anything other than my explanatory variable that might actually be the cause. A confounding variable has to be connected to both my explanatory and my response variables. So whether or not the class was taken was my explanatory variable, the SAT score was my response variable. We do know there's a correlation between these two, but it could be that available time or motivation level, motivation level might be connected to whether or not they decided to take the course. Motivation level might also influence their score, whether they took the course or not. So there might be this other thing at play that is explaining this correlation that I'm seeing. When you are asked to identify possible confounding variables, and this was absolutely on last year's exam, you don't just say, oh, this is a possible confounding variable, period, the end. In order to establish it as a confounding variable, you have to tell me how that thing is connected here and how it's connected here and how it could be influenced or influencing both of those things. So you have to establish, if they just say, what is a possible reason for seeing this? You can't just be like, oh, motivation level, period. I'm done. Yes?
So we do that by drawing this type of chart?
I would probably put it into a sentence form. I use the chart to kind of organize my thinking, like what else could be going on here. Normally when I think about it, I don't put it in a visual form like this, but sometimes those like mind maps help people think through what could be causing this or what would be a potential confounding variable there. Designing an experiment. So we already said that an experiment has to have what? Has to have what? Control group. So we need a treatment group, we need a control group. That means we have to decide on a treatment. That's the thing our treatment group would get that our control group doesn't get. What would our treatment be in this case? Yes?
I have my experiment that was kind of long.
Oh, read it.
I said students take the SAT without prep the year before, then they take the prep class next year and go on to take the SAT. If the scores are higher, we'd be able to determine a strong correlation between prep and the increased test score. If they perform the same as last year or the year before, or if they perform the same as the year before or worse, then we know the SAT prep doesn't affect the test score.
I love almost everything about what you wrote there. Absolutely. We're going to talk a lot more about how to do a well-designed experiment, but I love so much of what was in your explanation here. One of the really important factors with an experiment is the idea of randomization. So the only big thing that I saw in your design is that it doesn't take into account other things that people might have done between the 2 years. But it would help me establish a very strong correlation, yes. My experiment should help me determine cause. And so what I wrote for number 5 was that we're going to randomly select 100 juniors to be part of this experiment. Randomly assign the participants to 2 groups. You want to make sure that you don't get You know, your top 50 students in the SAT prep group and your bottom 50 students in the non-SAT prep group. So they have to be randomly assigned here. So we randomly pick the juniors, and then we also randomly assign them to one of these two groups. Require one of the groups to take the prep class, and the other group is not allowed to take the prep class. 1 month later or 2 months later or whatever time frame we decide on, have all 100 students take the SAT and compare the scores between the two groups. One of the things, Ben, that I really liked about your design is that you had people being compared to past themselves. That's a really powerful design method where you compare someone to themselves. That often helps us control for other possible confounding variables. So I loved that in your design. Definitely want to point this out. You need to be able to describe, I don't know why it's not zooming in for you guys. Hold on. There we go. Now it's much bigger. You need to be able to describe in detail how you would go about randomly assigning these. All right, so we've talked already about how to randomly pick our sample. We could do a simple random sample. We could do a stratified random sample. We could do a cluster random sample. So we've talked about ways to pick out those 100 juniors. How would we randomly assign them to two groups? Being able to describe this. What are some ideas you have about how we could randomly assign them into these two groups, either control or treatment? Anthony.
So like written them in a systematic, the systematic one where you go one group two, just on until you get all 100 students.
Okay, so I would say one thing that would be really important, I like that, is that you would have to like somehow randomize the students' names on the list, or maybe you assign a number to them. And then you have this random sequence generator spit them out in an order that's not 1, 2, 3, 4, 5. And then you could do every other. There has to be this aspect of randomization in there. Another thing that you could do is you could label those 100 juniors 1 through 100. You could use a random number generator to pick out 50 and assign them to your treatment group. One thing I've seen the AP readers get really picky about is if you talk about who's getting assigned to the treatment group, but then you don't mention what happens to the other people, that's not counted as a complete design. You have to actually state the other 50 unselected students would then be assigned to the control group. You have to state that. If you don't, it's considered to be an incomplete design. So you can write it out in words. One of the other ways that I have seen this done is by kind of making a map out of it. So starting off with, I've got 100 juniors. Those are my experimental units. We're going to randomly assign them. And again, I would need to go into detail about how I'm randomly assigning them. I would need to show my two groups. I've got group 1 and group 2. Roughly equivalent. Again, if I had 101 participants, I'd have like 50 in one and 51 in the other. I want them to be about the same, as close as possible. Then I have to state specifically which group gets what. One group gets the SAT prep class. One group does not. Those are my treatments. Ideally, the only difference between those two groups is whether they took the class or not. That's why this random assignment is so important. Random assignment between the groups means that if there's somebody that doesn't get a whole lot of sleep or isn't super motivated, I end up with people like that in both groups. If I end up with somebody who's like, I absolutely have to do good on this because I want to do really, I want to get into my college of choice, I've got people like that in both groups. So we're trying to control for those confounding variables by doing this random assignment between the two groups. So that ideally the only difference between the groups is whether or not they received the treatment. And then this is really, really important. I set it up here in words. I showed it in my picture here. You have to say that you're going to compare the results at the end. If you don't compare the results, You've got two pieces of information and you found nothing out. You want to compare those results then to see which group scored higher, or did they score about the same? Did this make any difference at all?
So if you did the math, would you need to do like all of that, or just the part of the black?
You would need the part that's in the black, and then somewhere you would need to actually flesh out how you are randomly assigning them.
The red.
Yeah, the blue and pink and orange and green, that is so that you guys know what those vocabulary terms mean, because I have seen them say, who are the experimental units, or what are the experimental units? You gotta know the vocabulary and terminology there. Yes?
Could I not just say that correlation and causation?
Yes. Yes, you can. That's exactly what I would put for that. All right. Real quick, this is already printed in your packet. We'll start with the check your understanding tomorrow. But please make sure that you take a chance to look at kind of our important ideas from what we went over today, especially this idea of confounding variables and how we go about random assignment.